Anyways, we did postal codes, so postal codes, passwords, they're all game, right? Remember, guys, what are we doing here? Supreet, pay attention now. What are we doing here? We're always trying to find out how many possible options do we have. If I keep on, first of all, we do the universal, but then I keep on adding restrictions on you, and then things change, right? There are a couple of things that I want to warn you about. I think it's going to happen right here, the RRV. I was thinking about it last night, and I think I'm going to suggest something to you to prevent mistakes. There's a common mistake that happens all the time when it's the OR. The way I do it is the faster way, but probably the more dangerous way of doing it. So I'll show you how to tackle those ones. So to go to page 5. So what if no repetition is allowed? And remember, we're always following this pattern of letter, number, and so forth. So we have 24, because I and O are not available. So you've got 24, 23, 22, right, when it comes to the letters. And here for the numbers, we go 10, 9, 8. So this, in a sense, if you multiply this all out, you get 8,743,680 codes, or postal codes. Okay, are we good there? The first letter must be an R. Okay, so that 1, 2, 3, 1, 2, 3. So let's put an R there. You don't have an option. It has to be an R. Okay. Oh, no. Reload. There we go. So that just gets a 1. Okay. And then repetition is allowed. So for this letter here, we would go back to 24 and then 24 like that. And this would be 10, 10, and 10 like that. Okay. If you multiply this out, maybe if you want to go a little shortcut, 24 happens 2 times, 10 happens 3 times, right? So 24 squared times 10 squared, so you don't have to type in all of them individually. That's 576,000 codes. Okay. I'm just going to say, one year there was this on the exam. What could you do? So the city is running out of codes. What could you do to allow for more codes? That was one of the questions one year. Just, you could say, add another digit, right? Make an option for another number, another letter. You could say, maybe implement I and O, even though it would mess up a lot of people, right? You could still say that, right? So keep that in mind. The more options you have, the more codes there are. The first letter may be an R or a W. No repetition is allowed. So 1, 2, 3. This is where I'm going to say, maybe let's do it this way. This is R, okay? And then so if I've used up R, that means that I have 23 here and 22 there, because I can't repeat, okay? And then this would be 10, 9, 8. And then you will go with a V here. And you can copy it, right? You know it's going to be the same. But then that way you see, right, that this is 23. Because what I have happening a lot is students put 2 down here because it's R or V, right? And then they'll go 22 because they'll subtract the 2 from 24 and then go 22, 21, and so forth. Really what's happening is that you're going one branch and then the other branch, and you're getting them separately. So this is 364, 320, 364, 320, and then you add them up to get your total, 728. And if you tell me, Mr. Dixon, that's not going to happen to me, if you promise me it's not going to happen to you, then you're fine. But if it's the ORs at the start, you got to treat it like this, that it's happening for each option. For R, it's happening, and then for V, it's happening as well, and we're adding up the totals, okay? E, repetition is allowed, but no vowels can be part of the postal code. So A, E, I, O, U cannot be used. These are already gone, right? They've already been removed. So now you're removing these as well, okay? So 3, 3 additional letters removed. Let's make a note on the side, because when you look, ooh, you can't even see that. Please let me know when that happens. So 3 additional letters removed. So you used to have 24. Now you're going to go minus 3. You have 21 available. Okay. You have 21 available right now. So we go. So repetition is allowed. So we go 21, 21, 21, and then 10, 10, 10. What is that? That's you'd be 10 to the power of 3 times 21 to the power of 3. If you multiply that out, that's 9,261,000 codes. And this is just an aside here. Okay. How many codes have how many codes have start? That doesn't make sense. But how many codes start like this? Okay. Repetition is not allowed. So, yeah, you can think of it this way. It's R3G. So there's only one option for the first 3 slots. Okay, so you really only have a say here. So this would be, I've used 2 letters already, correct? So this would be 22. And I've used a number already, so this would be 9 and 8. Okay, so that would be one answer. And then you could go R4P. There's only one option for each. And we can copy the rest down. Okay. And then R5E. There's only one option for the first 3 slots. And you can copy down the rest. Oops, sorry, it has to be on top. Right, still 9, 22, 8. Because the second half of the code doesn't change, right? It doesn't change in terms of these cases. It stays the same. So what do you get there? I don't have this one on mine because this is brand new. So 9 times 1584. 1584. And because everything stayed the same, so we're going to add them up, okay? And that will be, so basically times 3, so that'll be 4752 codes. How many codes contain only letters R, L, or M? Repetition is allowed. How would this change without repetition? Let's do one. This is with repetition. So 1, 2, 3, 4, 5, 6. You can only use these 3 letters. So technically you have 3 options here. 3 options there. 3 options there. And this is 10, 10, 10. Okay. So this would be 3 to the power of 3 times 10 to the power of 3. This is 27 times 1,000. It's 27,000, right? Without repetition. You have 3 at first, and then you're down to 2, and then you're down to 1. 3, 2, 1. This would be 10, 9, 8. Again, this is letter, number, letter, number, letter. Okay. So this one, let's see here. This is 2 times 3 is 6, times 10 is 60, times 72 basically. 4320. No repetition. I'll do a couple more, and then I want you to try a couple again in class. Get really comfy with these type of questions. Basically, if you make it through the first couple of pages, the first 10 or 12 pages, there will be passwords, there will be postal codes, license plates, roads, like how to get to a place taking number of roads, like all that kind of stuff, it all falls under the same category. We're finding out how many options there are. Okay, let's go to page 6. I'll give you some visuals on this one. Very, very classic. This one is very classic, okay? John did not study for his test and wants to answer 3 multiple choice questions. There are 3 multiple choice questions. Each question has 4 possible answers, A, B, C, D. How many outcomes are there? I want you to use the fundamental counting principle and some sort of visual representation. So that would be a tree diagram or an outcome table. You can do a tree or outcome table. That's what the province means with a visual. Venn diagram would also work, but I don't think it would apply in this case. Okay. So let's do the fundamental counting principle first. So you've got 3 questions, correct? Question 1, question 2, question 3. Okay. And each one has 4 possible answers. So it'd be 4 times 4 times 4. So this is 4 to the power of 3. Okay. And 3 multiple choice, 4. Okay. 4 to the power of 3, that would be 64. Yeah. This is optional. I don't necessarily require this. Like if you just give me, okay, outcomes. So ways to answer. I will say that ways to answer. And if you think about it, the first question has 1, 2, 3, 4, like A, B, C, D. Okay, I think this is going to be very hard to do, but let's try it anyways. And then you've got A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Okay, this represents, like if you had question 1 and question 2, right? And then you have a third one. So every single one of these has 4 coming off. Just try your best. Yikes. We'll stop there. I thought it was going to work. But I promise you there's 64 branches here, if you count them, right? So there'll be 64 branches. Okay? Obviously, when it comes to this many, I would not make you do a tree diagram. It would be too crazy. But you should be able to know what is expected in this case. Okay. B, how would the outcome change if he eliminated 2 options for each question? You know, the obvious ones. There's usually obvious ones that don't apply, right? What is the difference in outcomes? Okay. So how will that change? Question 1, question 2, question 3. So how many options do you now have for the first one? You're only considering 2, right? And then 2, and then 2. Okay. So 4 options minus 2, right? So that's 2 left. You only have 2 options left per question. So now it's 2 times 2 times 2, which is 2 to the power 3, which is 8 options. How is that different now? The difference would be 64 minus 8. Okay. And that would give us 56. Fewer options that you would have. If you were actually able to narrow it down, there's a lot less to consider, right? We're down to 8 options only. So finding the right one is a lot easier in that case. I want you to try this one here. Very similar to what we just did. Read this one and see if you could do it with a fundamental counting principle. I don't need you to do a tree diagram. I just need you to do fundamental counting principle there. Yeah, if you just look up here, there are 6 questions, right? These are my events. There are 6 events here. Okay, so each one has 5 options, right? So 5 times 5 times 5 times 5 times 5. So that'll be 5 to the power of 6. Okay, 5 to the power of 6 is 15,625 ways. By the way, how many ways are there to get them all right? To get every single question right? It's only one way. Right? 1 times 1 times 1 times 1 times 1 times 1. There's only one answer. It'd be 1 out of 15,625 ways. Okay? So keep that in mind. Okay. Example 7, if there are 5 racers competing, how many ways can the first, second, and third place be arranged? Note, since we are talking people, there can't be repeats in this scenario, right? Like you can't have, so write this down. This is also classic. So first place, second place, third place. Okay, there are 5 racers. So you only have 3 slots to fill the 5, right? So it'd be 5 options to win the first prize, right? Being first in the race. Then there are 4 options to have somebody coming in second, and therefore 3 left for third place. So this is 5 times 4, that's 20, times 3, that's 60. 60 ways. Okay. Next, how many different words can you make with the letters in the word boring? Because I was thinking of this lesson when I was making this one. So just so you know, limited supply, write this down, limited supply. So if the question is saying, literally, you got to use what's in that word, you don't have repeats, right? You can't repeat. You can only use whatever is in this bag. Imagine they're cut up and they're placed in a bag. Okay, that's what they mean by these types of questions. So how many spots do we have? 1, 2, 3, 4, 5, 6 letters. Okay, 6 letters. Okay, so this, in this case, all you would need to do is this. Watch. You go 6 times 5 times 4 times 3 times 1. Is that 720? Yeah, 720. There's going to be an easier way down the road for this. When you see 6, 5, 4, 3, 2, 1 like that, I'm gonna tell you that later. So ways or words in this case. With the words make sense, not necessarily, but that's how you deal with that. Keep going. I'm gonna let you work on 7 soon. Let's go to 8 for a bit. I want you to do the roads from a city to another city. Okay. Page 8. There are 5 roads from Winnipeg to Banff and 4 roads from Banff to Castlegar. Okay. If you cannot travel the same road twice, this is a big must, right? That's important. Highlight that one. You can only travel each road once. How many ways can someone travel from Winnipeg to Castlegar? Let's do this here. We'll go Winnipeg to Banff, right? There are 5 roads that connect them. So we're going to go like this. 1, 2, 3, 4, 5, right? There are 5 roads that connect it. Do they look exactly like this? No, we're not told. They could be zigzag, it doesn't matter. But we have 5 ways to get from here to there. And then from Banff to Castlegar, we've got 4. 1, 2, 3, 4. So there are 5 here, there are 4 there. So to get from Winnipeg, it says from Winnipeg to where? To Castlegar, there are how many ways? You got to go from Winnipeg to Banff, and then you got to go from Banff to Castlegar. That's the idea here. So you've got 5 roads that connect these 2 cities, and then you've got 4 roads that connect the other 2 cities. So you, in a sense, have 5 times 4. You've got 20 ways to do that. And if you want to think about it, think of it this way. Road 1, and then road 1 here. And you could go road 1 here, and then road 2 there. Right? So there's 20 ways that you could actually go from one city to another, given these circumstances. Oh, I just answered that here. How many ways are there from Winnipeg to Castlegar? And it was there too. So just say, hey, I already answered it. Why are you asking again? How many different routes are there for a round trip? Watch here. How many different ways are there for a round trip? So from Winnipeg to Castlegar, then back to Winnipeg. I will make this note. I know it says it up here. It says it up here. You cannot travel the same road twice. Can't travel same road. So you're basically going from Winnipeg to Banff. Your second event would be Banff to Castlegar. And now you got to go back, right? We're going to go from Castlegar to Banff. And then from Banff to Winnipeg. Okay. So what number should we plug in there, folks? From W to Banff, that's 5. And then you've got 4 from Banff to Castlegar. How many are left now from here to here? 3, right? You only have 3. And from Banff to Winnipeg, you only have 4. Because you used to have 5, but you already traveled on 1. So we're just assuming we have 4 left. So if it's a round trip, you got to go there and then back. But it's and. You're always multiplying your options. So here we go. This is 20, right? And this is 12. So 240. So just read the question carefully. Okay? 240 ways to make that trip there and back. 240 different ways. Okay? And I want to do the coaches here. Taking a picture, that's also a classic. Taking a picture. Let's go to that one there. A team of 10 people are lining up to take a team picture. It consists of 8 players and 2 coaches, right? Hence the 10 people. How many ways can the team line up for the picture? So you got to think that there's 10 spots to be filled in. I'm a big fan of these blanks that you create here. So that's 5, 6, 7, 8, 9, 10. So you have 10 to fill the first spot, and we're talking people here, right? So you can't use the one you've already used for the first spot, you can't use for the second. And then you have fewer there, so you just keep. This goes down all the way to 1. That's going to be 10 factorial later on. I'll explain that to you when we get there. But what do we get when we do this? I have, you get 3,628,800 ways to line up. Okay, we count every picture as a different picture if you switch the people, right? They're all unique. Okay. How does that change? How many ways can a team line up with a coach, right, that must stand on either side? A coach needs to stand on either side. How is that going to change? Let's make our 10 lines here. That's 6, 7, 8, 9, 10. So you have to have a coach here and a coach there. Let's figure that out first. So a coach there and a coach there. But there's two coaches, right? So let's say this is coach number 1 and this is coach number 2. Okay. How many are left now to fill the remaining slots? These are the players, right? We've got 8 slots to fill. So you'd go 8 times 7 times 6 times 5 times 4 3 times 2 times 1. Everything is multiplying. What do we get there? What is it? 40,320. Sounds right. But is this it? Is this the only way? This is where you could put this coach there and this coach over there. So we actually are doing this twice. Okay, guys, we're doing this twice. So I won't fill this all in again. I'm just going to show you. This is coach 2. This is coach 1. So you still have 1 and 1, and you fill in the rest here. Do you want to do it again? These are your notes, right? 1, 2, 3, 4, 5, 6, 7, 8. So it's 8, 7, 6, 5, 4, 3, 2, 1. That's also 40,320. So I want you to think of this as the or, okay? So it's either this scenario or this scenario where the coaches just flip-flop. Down the road, folks, you're probably just going to take this one and go times 2. You're just going to see it. Oh, coach on either end, but they can flip-flop, right? So this whole thing is happening twice. Yeah?
Why can't you just put like C and C and then 2 and 1?
You can. Absolutely. The reason I'm not doing that right now is because you're still in the stage, and if you see it, go for it. You can absolutely go 2 and then 1, and you'll be fine. Yeah. I just want you to. Usually when I just jump the gun, students are like, what? What did you just do there? Right? So if you see it, perfect. Let's add it up. We get 80,640, right? Ways. However, will this be close to my universal? Right? It will always be less than universal. This is like no restrictions whatsoever. We're just lining up. Who cares if the coaches are in the middle, on the side? But this is only the ways where the coaches are on either end. That's it. Like you can't mix them up, okay, amongst the players. So I think at this point, I'm going to ask you to try pages 7 7, 11, 12. 7, 11, hey, your favorite place. Keep on closing down though. Page 7, 11 to 12 for now. I did ask you to try 9 and 10, I believe. So those are still there. But I would like you to first try these pages. Make sure you work. This is your chance to be like, I don't get it, Mr. Dirksen. Can you try and explain it a different way? This is your chance, okay? Don't wait until it's too late, because a lot of it will rely on this knowledge, okay? So go to town, take a bit of time,